Those of you who don't know me, I have been qualifications manager at SQA now for 21 years. That's why I've got no hair left. Before that, I was principal teacher of physics at Grange Academy in Kilmarnock. Don't know if I've got anybody from that neck of the woods in. Oh, the Joes, right, okay. So, yeah, they used to send their SYS stroke advanced higher candidates to me. All right. That's probably because I'm not there. Norman invited me along to come and talk about advanced higher projects and higher assignments. But I'm going to start with the advanced higher projects. Now, I apologise if some of this is like, I know all this already, Andy, I've read the documentation. But sometimes actually somebody just saying to you, look, this is what the documentation says, this is what it means, blah, blah, is actually easier than sitting reading it yourselves, okay? Especially if you're in the unfortunate situation of being like a single teacher department with a faculty head who's not a physicist, for example, and you need that kind of support and interpretation. So, for the project, we have a document that we kind of refer to as the course assessment task. One single document in which you've got instructions for yourselves. You've got the marking instructions. And it's the marking instructions that our markers use as well. It's not like there's other things hidden away, that's what's there. And then most importantly, the instructions for candidates. And I would say right at the outset, when you're first planning with your own candidates around what they're going to do for the project, give them a copy of the instructions. Make sure they've got it and they're familiar with it. It's not meant to be a secret, you know. There are lots of things in there, you know, even how to reference and examples of how to reference. It's all in there. And if candidates follow it, then they can often score good marks. You know, I often get asked, what are the good projects? And my answer is always the ones that are written up well. You know, I have seen some people don't like acceleration due to gravity. I go, oh no, you never get a good mark with that. And I've seen 30 out of 30 reports for that. Equally, I've seen 5 out of 30 because it depends upon what the candidate's done, how they've written it up, how they've analysed things, you know. So there isn't an idea like these are the topics to do. There are certain ones that come up time and time again because they're tried and trusted, and they can either be done with kit that you've got in school, or and most of you are probably too young to remember this phrase, can be done with Heath Robinson type kit. I don't know if any of you had the sort of Physics for You books with the sort of press this, that knocks that, which does this. That's a sort of Heath Robinson type setup. I will leave this presentation for Norman to put online so that you don't need to copy everything out, and the links are live as well, so you'll be able to take those. But the conditions for advanced higher project are different to those for National 5 and higher, in that both the research stage and the reporting stage are done under what we call some supervision and control. So whereas in higher or National 5, when it comes to the report stage, that's basically exam conditions. For this, when they're doing the report, that's done often in their own time. A lot of candidates like to type them, what have you, which is fine. You just need to have in place kind of, in a sense, checkpoints. You know? I mean, I always used to ask for a draft of the report before they were due to be sent away, because you are allowed to give advice and guidance. It just can't be like very directed. You can't say to them, by the way, the units in that table should be. But you might want to say to them, away and check your tables, again, just to make sure you've got it correct, okay? So you can't give them any templates. We have come across things like that in the past where it's like, schools thought, we'll have a template for our advanced hire project, or a template for putting the data in, which will then automatically calculate averages and plot graphs and things like that. That has to be their own work. You can't give them that sort of thing. You can't give them experimental data. That has to be data that they generate, and this has to be individual work at advanced high level. The other two levels, they can work in small groups to do their investigations, but at advanced higher, it must be individual work. They might occasionally need a pair of hands to hold something while they're doing things that wouldn't fall foul of conditions of assessment. What would is, let's work together on this, and right, we've got one set of results and we're going to share it between them. You can certainly provide advice on suitability of topics and aims. I think it's, in an ideal world, you'd be saying to your advanced higher candidates, what do you want to do? And then when they come back and go, well, I really want to investigate muons and muon detection and stuff like that, go away and think of something a bit more reasonable. We don't have the kit to do that, and I doubt you'd get the money to go to CERN or someone like that to be allowed to do the experiment. So it's you've got to give them something reasonable. I used to have a list of about 14 different topics, and did it on a kind of first come first served basis. Occasionally I would have more than 14, in which case I might have to have two people doing the same topic, but I was in a Grange at that time, had masses of great kit. I was talking to Norman earlier, we had 2 turntable spectrometers, for example, which I gather aren't there anymore. Probably went in the bin when they built the new school. So advice on safe and correct use of apparatus. Thinking when I used to have candidates doing charge to mass ratio of electrons and getting the Teltron tubes out, I certainly made sure that they knew how to connect them up and use them safely. I didn't just go, hey, there's the kit, on you go. And that's where kind of what we call reasonable assistance comes in. Making sure they're not going to electrocute themselves up. So, reasonable assistance is a term you'll see across all SQA documentation. And the key thing is the bit in bold about when you're giving a candidate assistance, what you cannot be doing is compromising the integrity of the assessment. So it said about if you're looking at a draft of a report, feedback needs to be generic, not this should say, this needs to be type thing, because that would be considered as being over-directive. And candidates do strange things, like leave post-it notes on reports, and the marker opens it up and goes, oh, there's a note from the teacher here telling them to change this to that. That's not appropriate. So, but there's lots, I'm not going to linger on that because there's lots of stuff on our website about what constitutes reasonable assistance. So, what should they be doing for their projects? Well, basically, the research stage need to plan their experiments. Okay. That might be around what experiments, what apparatus you've got. Sometimes a candidate would want to do something that I didn't have. I didn't have, for example, a Cater's pendulum. And what I used to do was, okay, he's not there anymore, but I would give Ronnie Brown, I had Ronnie Brown's phone number, gave it to the candidate, and it was like, I went and phone Ronnie and ask him if you can go and use their kit. Now, I know last year there were issues around, Glasgow weren't doing anything like that. The labs at Strathclyde were being refurbished. I don't know if Heriot Watt were still offering, things like that. But one of the key things, and one of the things around sort of an appropriate level of demand, is you're looking for them to spend 10 to 15 hours on experimental work. Not an afternoon in a lab, not a day at Heriot Watt, because what they're then going to find is that they get hit on various sections of the marks because they haven't done sufficient. When we're looking at level of demand, one of the things we consider is how long a candidate would spend on it. Now, I know I might be able to go, right, Teltron tube set up in jig time, and, half an hour, I've got all the results I need. And for a candidate, that might be 2 or 3 hours that it takes them to do that. So what we ask our markers to do is think about how long it takes a candidate to do it. Okay? But that kind of, if you're thinking, am I getting the right level of demand? Then you're looking at that sort of volume of experimental work and at advanced higher level. We get a lot of candidates who like to do like an introductory experiment. G is a very popular advanced higher project. And you might find that one of the experiments they do is they get the trapdoor and the falling ball out and vary the height and do things like that, which is really a higher level experiment. So that sort of thing is fine as like, here's my introductory, but they then need to go on and do sufficient work at advanced higher level. If that's one of their 3 experiments, and we recommend kind of 3 to 4, they might find that the marker's looking and going, well, that's just a higher experiment. So they're not going to get full marks for level of demand, if that's the case. Okay. So, and again, this is where your guidance comes in for them, is to kind of go, right, if they're going to go, I'm going to drop a G ball, and that'll give me a direct value of G, and then I'm going to drop a ball bearing through a trapdoor, and then, okay, I'll do the compound, or the simple pendulum. It's going to score very lowly on level of demand. Plus, with the G ball, it's like, how are you analysing that? Oh, it told me it was 9.81. Type thing. So that's the type of thing you want to be guiding them into something that's more appropriate for the level. It cannot be computer simulations. I got asked this at an Understanding Standards event. Can they use computer simulations rather than doing actual experiments? And no, this is all about doing experiments. Computer simulations are set up to be perfect anyway. You're learning nothing from press a button. Oh, look, this is what it gives me. Whereas, the idea around this is they're having to manipulate things, do things, take their own readings, analyse their own readings. That's the thing that the universities tell us is so valuable for moving on. They need to repeat things. Now, sometimes it's not always possible. I remember having a candidate who was looking at viscosity of used engine oil. Well, new and used. He got samples from a local garage of been in for 5,000 miles, 10,000 miles and 20,000 miles. But he then decided that he was going to stick the oil through my Ostwald viscometer. And each reading was taking 2 hours. And it was it just wasn't feasible to repeat that. But that became part of his evaluation on that particular bit of the experiment. I didn't kind of forgive him for doing that with the viscometer. He was then attaching it to a vacuum pump to draw it back through as well, which was not great. And then you're looking for them to decide range and interval for each experiment. As with the lower levels, there might be health and safety issues where you've got to go, no, you're not going above that value. Right? So again, feel free to step in at these points and, make sure that they're not going to do something that's going to be dangerous for them. I said typically 3 or 4 experiments. Occasionally you might end up having a candidate doing something whereby, after 15 hours they've managed two things. The one that always springs to mind is if you've ever had anybody doing Cavendish buoys properly, which takes hours and hours to get a decent set of result. So, in some cases it might be that there are 2 experiments, but typically aim for your kind of 3 or perhaps 4. But if you are finding they're doing something that is so complex that they can really only fit in 2, we'd expect our markers to be able to look at that and go, oh, crikey, doing Cavendish buoys that way takes forever. Right, that's okay. That's suitable. I remember sitting in a lab myself doing Millikins, and especially trying to do it by changing the charge on the drop using a source to ionize it. That was a whole day lab, to do that type thing. So it's a guide. There might be cases where it kind of sort of falls underneath that. I've mentioned about you need to make sure using the stuff safely and correctly. No blank or pre-populated results tables. Data. I mentioned already, so jump on to the next thing, which is it's not a requirement anymore for people old enough, or even those that did it, you might remember keeping your daybook. And it used to be when we had interviews that went along with these, somebody would come out to your school and interview you about your project and allocate marks for that. One of the things that you had to do is take along your daybook, because there would be things in there that you hadn't put in your final report. So it isn't a requirement, but it's a recommendation. Get your candidates to keep what I would call a daybook. It doesn't have to be a physical book. It might be electronic, but where they note down everything they're doing. Really useful for things like where they're getting their sources of information. You don't want them getting to the report stage and then going, where did I find that again? And then having to waste time going off and leafing through a 5th edition of Tyler and finding that. And then going, right, okay, I'll try the 4th edition. No. Oh, right, I found it in the 3rd edition. If they note that down straight away in their daybook, when they come to write it up, it's all there. And that can be useful for things like their evaluations as well, where they're having issues and problems. And then jot them down and keep them within that, because it really, really helps when they come to producing the report. So it's not mandatory, but it's a strong recommendation from me to do it. And especially as well, they're doing research out with your supervision. They might well be sitting at home looking up background physics for these things. And if they're noting these things down in a daybook, it's useful. I used to have this thing for monitoring progress where once they'd all decided, make up a spreadsheet with the experiments they were doing and the names of the candidates, and then when they finished a particular bit, they'd tick the spreadsheet, and then I'd be going, right, Norman, I see you've done that bit. Let me see your daybook. And that was the way I kind of think. Now, not every candidate will do that. I had situations of, the day that they're going off, picking up the phone and going, Craig, where's your report? I'll get it to you. They're going away today, type thing, and then straight in the. No surprise when it came back that he had done very well, type thing. So they're really useful for checking progress. If you see them going off at a tangent, give them some advice to bring them back to where they're going. A few of these things I've mentioned already. Needs to be advanced higher level of demand. The experimental work must generate numerical data. It's not like chemistry where they might be doing observations and going, oh, it turned blue, or what have you. In advanced higher physics, we're looking for numerical data, and ideally data that you can analyze graphically using scatter graphs. We still see the odd bar chart in an advanced higher investigation, and markers don't really give that much in the way of credence to things. You're looking for scatter graphs, and you're looking for experiments that they can analyze graphically, because the analysis marks, that's what the markers are looking at. What have they done for their graphs? How have they analysed the graphs? How's that? That's, what's the gradient? They can, of course, it doesn't have to be hand-drawn. Lots of candidates do still like to hand-draw their graphs, what have you. They can use Excel for these things. The key thing about using IT for graphs is they need to be able to use it properly. We do still see issues around, what I would call postage stamp size graphs, where they've gone, right, I've done it in Excel, paste it into my report, and then the marker's looking at it and going, I can't actually read that. It's so small. Or they don't know how to change the point markers, and so you get the huge diamonds that cover, 4 minor grid lines and what have you, which again, it's like not suitable. So they do need to know how to use it properly. But if they do know how to use it properly, then getting things like the line S data is really useful, because that will give them gradient, it'll give them uncertainty and gradient, it will give them, the y-intercept, the uncertainty and the y-intercept, just as a basic type thing, and that's all useful in terms of evaluation later on. If they're looking at a y-intercept and going, but the uncertainty is such that I could say this could pass through the origin within the realms of uncertainty, it's a great point to be making in your evaluation. So they can use IT for these things, and one of the things that we'd ask you to do when you're kind of picking or helping them choose projects, allow them to access all of the marks. If you're looking at a particular idea and going, no, they're never going to be able to pick up X, Y, and Z, then it's not a suitable topic, and look at something else. Okay. Either aim with you. Okay. You can't give them the aim, but they can come to you and go, is my aim okay? Type thing. So that's fine. And again, thinking about health and safety and what resources you have. So they may well have spent a bit of time, and this is what I used to do myself, is kind of like, have a look through there, see what you got, and sometimes they come back and go, oh, there's this really great experiment, I don't have a kit, can't get you the kit for that, so think of something else. Okay. But making sure that at the outset, even though they might not facilitate, do it themselves and actually make sure they're going to be able to get all the marks, you've given them the advice that would allow them to get those marks. Okay. There are some standard textbooks that people tend to use, whether you have them in your schools or not, don't know. Sadly, they're all out of print at the moment. The one that everybody talks about is Tyler, Lab Manual of Physics. I did a quick search this morning on Amazon and Abe Books, and at the minute they're a bit expensive. The cheapest one I found was about 38 quid. They come and go, and generally around about this time they're very expensive because people are going on and going, oh, there's one available, I'll buy it, and what have you. The 3rd, 4th and 5th editions are all in SI. Now, I know this sounds like I'm kind of giving my, SQA is giving approval to these books. They're out of print, but if you can get hold of a copy, they are great. Okay. A couple of others that are quite common: Armitage, Practical Physics in SI. as opposed to S1, as one of my colleagues used to call it. So this morning, there were a few of those round about the kind of £4 mark on either Amazon or eBooks. In fact, there was a seller in Dunfermline offering some. And then there's Nelkin and Ogbone, Advanced Level Practical Physics. This is going towards my retirement fund, because when I checked this morning, it was like £186 a copy or something. So, but there are lots of other practical books out there. Yep.
Can I just ask, I think the guidance says not, but are we allowed to give students a practical method, given that, if you don't have these books, it's very difficult to actually find some of these methods online?
No, some centres do because of that very thing. It's like you just got to be careful that your practical method isn't going, now here's your range, here's your interval, what have you. But I know some schools do have their own things for the particular kit they've got. I used to have a Jordan Hill air bearing turntable, which came with its own booklet of instructions, which I'd give to the candidate. Go, there's your instructions for that. So I think you just got to be, if you're doing your own, just be careful you're not giving too much direction. Sure. So it's the same. These books also tend to have theory behind the experiment in them, but one of the things that they do is they make huge leaps in the sort of derivations and things like that. And if your candidate is tempted to just copy down what's inside Tyler, then they're not really showing that much understanding. The better candidates will kind of go, hang on a minute, to get from step 2 to step 3, I need to do a couple of other steps, and they put those in. And then to a marker, that's like, oh, this candidate understands what they're doing, because they've put that missing sort of link in to the thing. So there are other books around. I collect, sad that I am old, physics books, and this is Experimental Physics for Schools, Parts 1 to 5, from goodness knows when. Shillings and pence, it was mentioned in. But again, within that, there are things you go, oh, that's a good idea, could do that. And often with kit that you could knock up. In terms of numbers, our rules around this are really quite specific and strict. If you've got 10 or fewer candidates, they have to be investigating something different. Okay. More than 10, then you can have people doubling up, but you've got to minimize the number doing each. So I can't go, right, I've got more than 10, therefore 8 will do G. And then one will do, Young's modulus, one will do Mersenne, one will do this. You have to manage that process to stop them. And yeah, there's meant to be an element of choice, but sometimes it's like, as I say, I used to do it first come, first served. And when somebody came along and went, I really wanted to do Young's modulus, I'd be like, tough. Louise has already picked it. So pick something else. And sometimes you might look as well and go, knowing your own candidates, actually, you might want to do properties of the electron, and the charge to mass ratio and millikins and stuff like that, but I think you're going to struggle with that. You might be better doing G using pendulum methods, so not a free-for-all, try and manage what they're doing, okay? And even where you have had to double up, you have to make sure there's no collusion between the candidates. They must have their own data. I know that's difficult because they can work away at home and they'll be on whatever social media they use these days, going, this is what I found, what did you find? Which, it's hard for you to manage. That you just have to make sure and tell them in front, you cannot do that. Okay. do we have anybody that's part of a consortium arrangement? Well, we do, because, yes, okay. I asked quite a few questions at Understanding Standards about this last year, because some centres were kind of falling foul of stuff in that. You really need to think about, if you're in a consortium, who is presenting the candidates, okay? Because if you're presenting them, you're responsible, okay? If a marker was to raise a suspected malpractice issue around something, and our malpractice team looked at it and went, I think we need to go and ask the school about this, kind of going, well, okay, yeah, we presented them, but I just left their own school to do the project. So you really need to go and speak to them. We'd be going, no, we need to speak to you because you've entered them. So if you are in a consortium arrangement, think about who is presenting them. If you're presenting them, and when I was at Grange, I used to have the attitude of, I'm doing all the work, so I'm presenting them. But then I also managed their topic choice for things. We had a few centres identified this year where it's like, there's 6 of them doing G by the same 3 methods. And I was like, oh yeah, that's because that candidate was in that school and that candidate. I was like, no, they're your candidates. So don't do that again, type stuff. So sometimes it's actually easier to go, no, their own centre presents them. Even though you're delivering and what have you, it avoids that sort of problem of anything happening down the line. That might not be how your local authority or your head teacher or what have you wants to work, because they might be looking and going, ooh, more insight points, if we present them. But have a think about how you do that, okay? The report stage, as I said, this is not sat down under exam conditions. Most candidates like to type reports. Quite often, they don't know how to use things like equation editor or math type. So it's not uncommon that what they'll do is leave a space and handwrite in the derivations, or do it on another piece of paper, photograph, paste it in. That's absolutely fine. We're not expecting them to be experts at using the likes of equation editor or math type. And we're not kind of tightly prescribing what you can do. The things at the bottom are things I've mentioned already that also apply to the report. Okay. If you can, getting in a draft of the report and then giving some high-level feedback is a good idea. Because, as I say, they might have, forgotten to do some uncertainties for one experiment completely. And I think you've forgotten something with this experiment. What is it you haven't done? Oh, I haven't done my uncertainties, right? Go away and do them. So, volume-wise, between 2,500 and 4,500 words, excluding lots of things. The title page, the contents, the abstract, tables of data, graphs, diagrams, calculations, references, and acknowledgements. We don't count any of those. And this is where, again, because they type them up, sometimes they'll just rely on Word. And at the bottom, Word says you've got 6,781 words, because it's decided that it's counting all of these things, and all the numerical entries in the tables, it's counting those as things. Our markers are asked, if a report is 10% above the maximum, to refer it to us. Or if they suspect a report is beyond that. We have had candidates trying to game the system by telling us that their report is, 4,499 words, and the marker's picking it up and going, 120 pages? Seriously? 4,000, Now, okay, sometimes it might be that there's 70 pages of appendices with all of the In fact, one I heard about this year, because the candidate hadn't set their sampling rate to something reasonable. They'd set it to something ridiculously small. They then had about 70 pages of data, which they added in as an appendix because they have to provide all of their raw data in the report. So that one didn't go over the word count. But we do get candidates kind of trying to pull the wool over our eyes. And literally anything that's raised or anything that's suspected, whichever member of the examining team has annoyed me or the principal assessor most, is given the task of sitting and counting the words. Sometimes it turns out to be, no, it's word and it's just counted all these things that shouldn't be counted, but other times it's like, no, this is clearly over. And if it's clearly over, there is a penalty, and that penalty is 3 marks. So whatever they've scored, it's like it's gone over, deduct 3 marks from that. So now some candidates might go, I'll take the hit because I can't be bothered editing this down. But, it's quite a bit, it's kind of, you can't exceed by more than 10%, so therefore we apply a 10% of maximum mark penalty. So they need to know that, that this is what happens. Actually, we saw a bit of an improvement this year in referencing from before the pandemic. Wondering if some of the bad habits of yore have kind of gone by the way. But referencing is something that quite often they struggle to do. We look at this, so we kind of got a progression for referencing across the levels. At National 5, you think, basically we want the full URL next to the data. They can cite and reference if they want, and then when you get to higher, it's like cite it and reference it later on, but we don't care about a particular system. So candidates might go in higher, reference 1, and then at the back, reference 1, and give you the thing. But at advanced higher, we want a formal referencing system, and the 2 that we say they can use are Vancouver and Harvard. There are examples in the candidate's guide of how to do them. My recommendation is tell them to use Vancouver. It's far easier. That's the one you put a little 1 or 2 square brackets next to the text, and then have that at the back. We don't get hung up about, these aren't in alphabetical order at the back and things like that. What we're looking for is, have they done 3 correctly? They might have 27. We want to see that they've been able to do 3 correctly. Okay. That's a useful link for them as well. College London has a great section on its website all about doing referencing. And actually, again, if they're using IT, there are lots of IT reference tools out there where you just need to stick in details of the book, the website, and it will format it properly for you, and then you just do copy paste. And again, there's nothing wrong with using that type of approach. Okay, so make sure that they've got the examples, and I think what we found this year more than before the pandemic was that they were sticking to those particular examples, and Vancouver was by far the most common style. Okay. Higher, I'll whiz through. Again, make sure your candidates have the instructions. Sometimes markers actually spot this. It's like, I'm reading this report now. Could be that the teacher's gone, these are the instructions, follow them. And knowing candidates, they go, nah, I know better. But I think sometimes it kind of comes across that, I don't think these candidates have had the instructions, because what they've done is kind of not what we're looking for. So make sure they do have them. The difference for higher comes at the report stage, in that is done under exam conditions, maximum of 2 hours for the write-up, unless it's a candidate with additional needs. If you've got candidates who in the exam are entitled to extra time, then that would apply to the write-up of the assignment too. Okay? So that's, if that's been agreed as things, then you need to make sure that they've got that. They might not use it all, but you still need to make sure that you're kind of meeting their needs. And as I mentioned earlier, for the experimental stage, they can work in groups of up to 4. Okay. But you need to make sure they're all kind of actively involved. If you see somebody sitting back going, nah, others can do it, that's your classroom management. Wait, you've got to do part of this as well, type thing. So, two possible routes at higher. One is very similar to National 5, an experiment and a secondary source. That secondary source needs to be relevant to their experimental data, not their kind of final conclusion thing. So a data book value at National 5 is fine, where they're going, I'm investigating specific capacity of copper. This is what I got experimentally, this is what the data book says. At this level, what we're looking for is experimental, as secondary data that can be referenced against their own experimental data. That might be a graph, for example, or a table of results, and not simply that Andy says in the data sheet on the exam paper that the value is 9.8. So it's that we step up where they've got to be looking at these things. Or they can do 2 experiments related to the aim. Typical ones we see around that are things like internal resistance. In the past papers, we kind of have questions where sometimes we're looking for the negative gradient giving you the internal resistance, and sometimes we use the setup where you get it from the y-intercept. So it's 2 different experiments that you analyse differently. Came across a few this year where the candidate clearly thought, if I do one experiment and analyse my results in 2 different ways, that would count as 2 experiments, but it didn't. It's 1 experiment, you've just done 2 sets of analysis. We have no strong preference. There are pros and cons to each. 2 experiment route, it's more time consuming. Some of your weaker candidates might struggle with that. Some of your better candidates might ace it, but it does give them like 2 goes at a lot of things. So if they're graphing, both experiments, a marker's told, mark both and give them the best mark. So if they score 3 on one graph and 1 on the other, they get 3. But you have to balance out. SQA doesn't have you must do this, you must do that. It's there as an option if you want. And you might have some candidates doing the first route and some candidates doing the second route. Or you might think, no, it's easier to stick to 1 experiment. When it comes to the experiments, I don't know if people attended understanding standards, but our advice is stick to bog standard higher stuff. Okay? It doesn't need to be anything fancy. In fact, often when it's fancy, what comes across is that they don't understand. Catherine was telling me this morning that she'd been showing you the getting refractive index using interference with water and things. Great as an advanced higher experiment as part of perhaps something around refractive index. But we saw a couple of candidates at higher this year with that, and it really, really came across that they just didn't have a clue what they were doing. Their underlying physics was all about, Snell's law says this, nothing about interference, nothing about small angle approximations. So that type of thing is like, keep that sort of stuff for advanced higher. Do not inflict it on your higher candidates because you may well be doing them a disservice. Okay. Internally, the experiments that are listed in the course spec, ideal for this sort of thing. Okay. So something we know they're going to understand because it's at the right level, and they can give us the appropriate level of physics. We saw a few that were at too low a level, And okay, they still picked up marks for, data and graphing and things like that. But where those ones tended to suffer was, again, the underlying physics, where you're looking at it and going, there's nothing above National 4 here, or National 5, right? They're getting nothing for their underlying physics, because there's no higher physics in it whatsoever. So, pick things that are appropriate to higher, that we know candidates will be able to tackle and they'll be able to tell us about. In terms of numbers, they can work in groups of 4 up to, and what we've said is within a class you must minimize the number doing this. So basically, if you've got a class of 20, my advice would be have 5 different topics and make sure each group works on something different. Okay. Now you might say to me, yeah, but they end up in kind of packets of 10 which go off to a marker, and by fluke they might get 9 that are all doing Ohm's law because they come from different classes. That's okay, the marker would still raise it with us, but I actually spent 2 solid days this year with packets from centres going through and going, actually, when I look across the entire centre, it's clear to me that this centre has actually had 7 or 8 different topics, and there's a reasonable number doing each. Also found somewhere it's like, no, they've got 3 topics and 90% of them did Ohm's law. And it's like, so in those cases, those centres got a letter saying, don't do it again. Type thing. So minimum 5, if you can get more than 5 for them to choose from, then that would at least give them a choice. But you need to manage that. You can't have a situation of going, well, I gave them a choice of 5 and they all picked Ohm's law. Because we would go, well, no, you were supposed to manage that and minimize it. So that would be my advice around number of topics and what have you. You can't give them any templates. That includes things for results, or, stick your secondary source here and put your URL below it here and things like that. That's something they're all supposed to be doing and collecting. Okay? You can't change the instructions for candidates. You might have candidates that need them enlarged or printed on elephant breath paper or what have you. That's fine. What you can't do is change the content of them. So we have in the past, didn't see any this year. I think we maybe got rid of that habit of, here's Joe Blogg's High School's Guide to Doing Assignments, and it's like, no, far too much help. So in actual experiments, you can give them the instructions, but the instructions have to be basic. Again, you can't say to them, this is the range, this is the interval type thing. Unless, again, it's like, yeah, but don't go above 12 volts. That's perfectly fine to tell them that. But they should be deciding what range and interval they're doing. And, risk assessment is, as the classroom teacher, your responsibility. So you need to make sure that appropriate risk assessment has been done for these things. What have I not covered in there? In your groups, they can have obviously you'll have a group of 4, all with the same data. You need to make it clear to them that they then have to do all their own calculations. Okay. What's not allowed, and sadly we came across examples of it this year whereby pupil X did all the calculations and then went, there you go, group, I've done it all for you. And that often shows up by the fact that they've all made identical mistakes. And the marker goes, hang on a minute, 4 people individually calculating this are not going to get the same wrong mistake type thing. So make it clear to them, once they've got the data and they've shared it in their wee group, everything else is their own. Okay. And you can't go, by the way, your data's rubbish. If they came to you and went, I think my data's rubbish, can I do it again? Yeah, that's fine, but you can't tell them. I've run out of time, haven't I? So I talk too much. Internet literature research must be their own individual work. That cannot be done as a group. So there's no kind of, I found these sources, everybody, here they are. It has to be their own. And when it comes to internet literature research, websites, journals, books, but please tell them not YouTube. I know it's one of their favourite things, but we get Mr. Stewart's YouTube video on, such a, now Colin's done some cracking YouTube videos, but they're not suitable as a secondary source for this. We can't be saying to the markers, right, can you go and watch that YouTube video for this? So tell them not to do it. You can't give them a list of sources to use. No resource packs. We did away with that before the pandemic because we were finding issues with what people were giving. So it's up to them to find. But if you keep it to the bog standard, they should have no difficulty finding things. In terms of the research stage, as I said, that's timed. Once it's done, they go in the envelope, ready to be sent off to QA. Do not be tempted to go, I'll have a quick read of these before they go, because that would be breaking the conditions of assessment. Their external assessment, much the same way as the chief invigilator would hunt you from the exam hall if you went down. Can I just have a look at my candidates' exam papers before they go? It's the same for the assignments. Do not feel tempted to do that. Or even worse, post on Sputnik. I read them all before I put them in the envelope and sent them. Yeah. So there's no feedback, there's no redrafting. Once the 2 hours is up, that's it. If you've got candidates pleading with you, I spoke to my tutor last night and she says I've done this wrong, can I redo it? No, nothing. Once it's done, it's done. Okay. And the other thing that we came across this year was some centres sending us photocopies of the candidates' work. It's the original we need. Okay, not photocopies. Because sometimes the things were clearly in colour that were difficult to make out on a photocopy. And if we'd had the original, we're like, oh, right, I can see. I've overrun. I always overrun. I talk too much. And I've kept off, taking 10 minutes off the next workshop.